Okay, so this part's kind of ugly, but I just wanted to continue the wiring on here. So I have the two 4s connecting together with, let me zoom in here. So they kind of branch together there in the connectors that are included in the kit. I did have to get a couple more connectors and a little bit more wire from Renogy to finish this up, by the way. But anyway, so I kind of ran all the panels under there. I used a Turnabond to hold down some of the connectors and wires, as well as some die-core in some various places. And then this solar panel, this 165 watt Furion, didn't really know what to do with this, and I decided I'm just gonna leave it. It's running independent to the base 12 volt battery that comes with the unit, and I'm running them completely independent of each other for now. What I did is I ran the wires underneath that stock solar panel, and then I didn't want to drill a bunch of new holes. There's a couple different ways you can run these wires through. I decided I was going to use the same gland port that was already used in my stock unit. This looks hideously ugly, so I apologize, but it works. And you can kind of see where I took the stock unit off. Obviously I've reinforced it back with some more die-core. In fact, again, probably need to do some more. And you can see I did this ugly thing on the side where I ran my own wires through the side. I drilled some holes and just kind of ran my own kind of forked gland over here. And then what I did to get those wires through, which I'll show you here right now, because it was kind of painful doing all the prep work. Running the wires and reinforcing this back area is probably the largest part of the install, to be honest. But this is in the front luggage compartment, and behind this wall there is the 2 wires that run in from the stock solar panel that go through here, and then this little panel. Of course, all these have to be removed so you can play around with wire management. But so what I did is I had to kind of drill out the hole a little bit bigger that was already in here, because the wires were obviously only for 2 and I'm making it for 4. And then what I did is I just used rope, some nylon rope I got at Home Depot. In fact, I'll show you right here. It worked great, by the way. This rope right here, I don't know, kind of, whatever. I just ran it from the top. Once I removed the gland, drilled out the hole there. And what I did is I ended up cutting the wires for this stock charge controller here, and I cut them up here, and then I taped the rope to those wires very, very well, by the way. And then I just pulled the wires through. That pulled the rope with it. And then now, once I had the rope both up there and down here, I was able to use it to basically run all the wires. I ran the 1 wire at a time, so I did the negative from my build, then the positive, and then reran both of the, then I had to run the wires that I cut back through the top to the bottom. Again, it was kind of painful, but it actually worked well. And anyway, so once those wires were run, they go using the same stock tubing here. Actually, no, I lied. I ran them from here down there, and ran them across, which I'll show you on this side. Sorry, it's been about 6 weeks, so I forgot some of the details. So here's where I have it coming out and running through to my solar isolator switch. So now that we're in here, first off, this has to be removed, because behind here it's just kind of almost, it's almost cardboard as far as its durability. So I'm hanging some pretty heavy equipment up here, so I wanted to reinforce it. So I put some more vertical 2x2s where, and horizontally where I knew I was going to mount some of these products. So I reinforced that really well. That was, and then once that was done, then I'll go walk you through left to right of how this is going, and then I'll share with you some numbers here. So this was not part of the Renogy kit, so I bought this separately. This is a isolator switch you can get on Amazon. I think this was like 60 bucks ish, something like that. I did get some extra connectors and wires, like I told you, and tried to color code it so we could differentiate between ground and power. The wires that come with the Renogy kit are essentially just black wires for everything. So anyway, so I wanted to add some colors there just for continuity. And then this is the 60 amp MPP charge controller mounted on the back wall of my luggage compartment. I don't know if you can see the readings right now. It's not really that bright out, but it's getting about 73 volts and 205 watts. At peak, it's about 90 volts the way I have my wiring configuration for the panels. And I was pleasantly surprised that, you know, because I hear a lot of things on the internet, you know, you're never going to get close to the rated max wattage. Well, again, this is an 800 watt kit, and in ideal sunlight, I was getting about 772, 775 watts, which is pretty darn close to 800 watts. So I was actually pretty impressed. Never peaked above 92 volts. Again, the way I have my array configured, which meets the minimum spec of this, which is well within tolerance of this. I think this maximum is 20 amps from the solar array, and then I think maximum voltage is like 150 or something like that. I could be wrong, it might be lower, but so the way I have is, you know, maximum is about a 90, and about 11 amps is the maximum. 11 or 12 amps is the maximum I could ever do with these panels. Anyway, so these run into the 3 Renogy Smart lithium-ion batteries I was talking about. I use 3/0 cable and these brass connectors for the battery terminals that I got at Home Depot. And then for the inverter connectors, I went a little bit bigger with 4/0 cable, which was the required spec for a 3000 watt pure sine wave inverter. Again, from Renogy. Here he is. And then from the wiring, I want to spend some time on that because, you know, online you can, so many people use so many different data elements and wiring configurations, and I mean, most of them are just, in my opinion, ugly and just a rat nest of bus bars every 5 feet, completely redundant and unnecessary wires. I wanted to go as streamlined as possible, but yet be efficient. I don't know if I accomplish it or not, but you can see that this is all of the wiring that I have. I don't need a bus bar, and I don't need a shunt, and I'll show you that. That's because of the batteries. The batteries basically have a built-in shunt, and that's the monitor over there that I'll talk about that actually shows you state of charge and how much time remaining. Much more accurate than this Bluetooth thing that you get with the charge controller. This is, I guess, good to know. This only really serves one purpose for me, and that is to know how much my solar panels are actually outputting to the charge controller. The charge controller will try to calculate using this how much the charge is, but it always pretty much says 100% because lithium-ion batteries operate a little bit differently than AGM or lead acid. But anyway, so so I have the wires. So I have a couple of fuses. Obviously, I have the switch here for the solar, for the charge controller. Then I have another switch coming to the, that's going into the, or coming from the battery to the inverter. That is then followed up by a fuse. I ran the fuse over here, not over there, because if the fuse goes bad and I want to replace it, I want to be able to turn the power off here, not have this proceed. That would be kind of silly. And then this is 400 amp class T fuse. I have it grounded here. There's a little grounding thing inside this, so I just put it up here. I guess it's working, I don't know. And then the Renogy 800 watt unit also, or kit also comes with this fuse box as well for the charge controller. I think it's 300 amps and an ANL fuse. And then one thing you'll notice is that I went vertical, so I didn't want to have a lot of cabinets, or I wanted to maximize the space I could to actually put stuff in my RV. So I mounted the inverter, which is pretty bulky, pretty heavy. I think it's about 65 pounds or so. But I made this little kind of cabinet that kind of housed the batteries, kind of protected them. And then I put the inverter above it. So far, that seems to be okay. I've only driven about 500 miles with it, but no issues so far. And then lastly, on, well, just the wiring, which I'm sure everybody probably knows, but when I use 3 batteries, so you want the kind of the negative to be, you want the positive negatives to be kind of opposites of each other. So on, we'll call it a battery array. So we'll call this battery 1. I have the negative charge from the charge controller and the negative from the power supply, or from the inverter, connected to that terminal. And then the positive is on the far end on battery 3. That's where the charge for the controller and the output to the inverter goes in, so that you maximize your battery bank in that configuration. So there's that. And then this is an inverter charger. Separate purchase, wasn't included in the kit. And what that does is, you know, inverter charger is kind of cool because you can wire it, which I have not done yet. That's what this one is for. You can basically run this to your fuse box, and there's a transfer switch that's automatically built into it. So as soon as you connect shore power, it'll automatically transfer and pull that shore power in to your normal operating fuse panel, and then it will use that shore power to actually charge the batteries. And then when you disconnect the shore power, it'll automatically switch over to the battery banks. It's supposed to be seamless, and there's no dropout in voltage. I do not have that wired yet because I'm trying to figure out where I want to put these, to be honest. One of the limitations to only having one 3000 watt inverter is that, you know, I'm only going to get, you know, at best 25 amps out of it, which is fine. And I don't plan on running, you know, 2 air conditioners off this thing or anything, and a microwave at the same time or anything stupid. I'm going to be a little bit smart about what I run. But this RV is rated for 50 amps. So I don't want to completely bypass the shore power with this unit, because then I would be shortchanging the opportunity and the benefit of 50 amps when I do plug in the shore power. At least I think. I'm not even sure if that's an accurate statement, but that's what I'm worried about. So right now, this is just for test configuration purposes only. I have only the output of the power inverter coming through this wire. Oh, let me go out here. Oh, and I just jerry-rigged from Home Depot a junction box for 30 amp plug with a 50 amp to 30 amp adapter. And this is my 50 amp plug, but of course it's only running on 30 plugged in. So I'm basically giving myself my own shore power as a test as I go through a series of tests. Okay, and the last thing I'll show is from these batteries. They're RJ45. You can they're smart batteries, and they have an RJ45 port on them where you can daisy chain them together, and inside each battery they kind of talk to each other, and they basically have their own built-in monitoring, shunt, state of charge, can calculate the amount of time remaining much more accurately than that Bluetooth device that you get with the charge controller. What's also nice about these smart batteries is they give you they double the charges you get. I think the non-smart lithiums are like 2,000 cycles. These are 4,000 cycles, which if you do the math, I mean, you're talking like 10 years of completely charging and discharging them for 10 years, which is pretty amazing. But what's also nice is then I don't need a bus bar, I don't need a shunt, which I think are the ugliest things you could do in a solar power install. And they just present more, you know, what I'm trying to do is reduce points of failure. And so, you know, a bus bar is worthless if you do the wiring right. Again, that's just a point of failure. And same thing with the shunt. So the fact that these smart batteries already have that built in, you do have to run another, actually a couple RJ45s. One, you know, obviously daisy chaining each battery. And then there's an output that I have run back through here, through the stock tubing. And then I cut out a hole here into this cardboard. I still don't have it mounted yet. And this is the battery monitor for the smart lithium batteries. I'm at 64.7%. If this were running right now on load, and there's nothing in the RV that's causing load, but in the upper right hand corner, which is really cool, but you don't see it, but it'll give a number of how many hours and minutes are remaining with its current state of charge. You can see here that it's detecting and talking to all 3 batteries. That's what that number 3 is there. You can see this is how many amp hours are remaining, 194.4. And you can see, well, I have my solar panels charging. It's being charged right now. It's going up. That's why it's kind of like your battery monitor. The AC should kick on here maybe in a little bit, and then you can see it'll start calculating how much still empty. I'm actually trying to run this down to 10 or 15% because I want to do a lot of testing of how long does it take to actually get it back charged to 100. And what's also kind of, I'll leave you with this kind of final thought, which I find kind of incredible. When I built this thing, again, this is only 300 amp hours, right? 800 watts, 300 amp hours. I'm in Florida and it's hot. And I never expected a build like this to run my ACs. I was like, there's no way. I mean, the AC is just gonna die, right? Maybe I get an hour out of it, something like that. Definitely won't run both of my AC units. But what's interesting is, and I'll show it to you, is that I can't get this thing, if I have the solar panel charge controller charging, I can't get my batteries to die. I'm actually kind of impressed and scared that I did something wrong. So again, AC is kind of, obviously I'm running a little bit high, but even if let me kick it down to, I'll kick it down to 75 so you can, okay, so now my AC's on. So let me do that. That's the only thing really running right now, right? But basically what I'm trying to say is running this AC, if it was at 100% when I started, which again I haven't, I've been draining it. I've been trying to drain the battery bank on purpose. Just the lowest I ever got it was what you're seeing right now. It's usually pegged at like 99.9. So here's a couple things really cool. So now that the AC is running and the power inverter is doing its stuff, you can see right here, it's saying there's 1.6 hours remaining, right? If this AC was going to run nonstop, this whole battery bank would be depleted in 1.6 hours, right? In fact, it just went up to 1.7. So what's interesting, again, at night, this would be very accurate at night, right? 1.6 would be all you get. But here's what's cool. Number one is, it just went back up to 1.7 because my solar panels are charging. And that's kind of the point I want to make is right now, especially at peak sun, is it's charging my batteries at almost an equal rate as that they're being discharged to run my AC. Now, what's also interesting, and I think this is why I'm lucky, at least for now, is that this AC doesn't run nonstop. No ACs do. They turn off for 10, 15, 20 minutes before they turn on again, right? So what's interesting is that little interval of time of 10 or 15 minutes once the thermostat cuts off because it reaches temp, that's enough to get the AC back to the rated state of charge that we began with. So what I mean by that is, if it says 2.4 hours remaining, and then I run my AC, it'll go down to 2.1 hours remaining. Thermostat shuts off, solar panels charge it back up, it kicks on in 15 minutes, and guess what? It's right back to 2.4 again. And I can't get it to go below that initial point when it's in full sun in the middle of the day. So what's interesting is that this is doing something I didn't expect it to do, which is it's handling my AC in Florida, keeping very nice temperatures, and during the peak heat, which is the time you need the AC most, that's also peak sunlight, peak power on the solar panels, and I'm almost completely replenishing myself during the time that the thermostat has the AC shut off temporarily. So it's kind of incredible. I did not expect that with just a 300 amp hour battery bank. I was really thinking I would never use the AC and maybe even need 4 batteries, 4 100 amp hour batteries in those cases. Now, again, this is brand new. I'm sure the batteries are going to degrade over time. I'm sure the solar panel performance is going to go down. I'm sure there's going to be really cloudy days where there's no way this is going to work. But right now, I'm at a very sweet spot from a balance standpoint, and it's exceeding my expectations. The overall design was to run my Starlink internet, TV, have some lights, and what I found is that I'm able to run my AC as well. So anyway, wanted to show that to you and share what I was able to do with this Renogy kit. Thanks. Bye.